Hello everyone, this is Aston Francis. In this presentation, I discuss FER Automation Case Study 4. I invented a device I called a First Event Recorder. It is similar to the SOE or Sequence of Event Recorder. It is also called an SER. This is an important piece of instrumentation used in power stations to record events or alarms. The purpose is to quickly find the root cause, why a generator tripped. Here is some background information. I immigrated from Jamaica to the US in 1993. Here is my disclaimer. I was never a power station operator. I am not an electrical power engineer. My training and expertise are in these fields of engineering: industrial controls, SCADA, telecommunications, computer hardware, software database, etc. I do not claim that this first event recorder met industry standards. It was built from locally available parts, and it was urgent. The improvements were in orders of magnitude. In this example, the manual method divided by the automation method results in around 360 times. That is 2 orders of magnitude. 3 is just a wild guess. It could be 1 hour. It would still be 120, which is over 2 orders of magnitude. It takes time to troubleshoot each piece of auxiliary equipment, to open electrical panels, to run diagnostics, to use meters to check various things. That takes time. So this is just a rough guesstimate. The objective is to find the root cause of the problem. I was a technician engineer in the ECS department at the JPS on Washington Boulevard. This was around 1984 to 1986. An engineer connected to the Hunts Bay power station approached me and asked if I could design and build a detector for a generator, which was somewhere between 30 to 60 megawatt unit. The purpose of this is to detect the first event or alarm that occurred when the generator tripped. Find the root cause. This was similar to the old SOE or SER that they had. It might not have been working, or they needed more points and locations to be monitored. Objective: find the root cause that tripped the generator. What event or alarm occurred first? I called this device the First Event Recorder. It had 6 digital inputs which could handle 1 kilo ohm loop resistance. It provided 20 volts DC control voltage, and it could detect events down to 320 microseconds apart. It had 1 reset button. The first event recorder looks something like this. This is just a mock-up It is about 8 by 3 by 6 inches. The FER systems view. Here are several pieces of equipment. Any one of these can trip and cause the generator to fail. 6 inputs are provided for this FER, and they interact. You have what you call cascading events or alarms. They are interdependent. One oil pump trips, something else is going to fail. A cooling fan or an extractor fan fail, something else will fail. When a circuit breaker trips, many other things will ripple through the system and cause the generator to fail. FER scanning. Here's a mock-up. This is slowed down just for illustration. It is scanning all 6 points at about 16 kilohertz. The unit looks like this. These LEDs are lit dimly, so you know it is scanning. You know the system is working. It is effectively doing a self-test or a lamp test. So you know it is not frozen, and this is a good feature. Here's an example of point number 2 activated. So the FER will stop scanning and point number 2 will illuminate bright. Then the power alarm LED will start to flash. It will stay in this state with number 2 lit bright and the power alarm LED flashing. It will remain this way until you push the reset button. So even a momentary pulse will still latch on to that state. They're just throwing a party because it worked. It caught the first event and the root cause that caused the problem. Here are some examples of what chips were used. This is a hex inverter, 4049. I used about 3 of these quad NAND gates. And here is the heart of the system, the CD4017. This is a decade counter, and each output will go on one at a time. So it scans from 0 to 9 and then reset. Here are documents I created way back at the ECS department in Jamaica, and this was around 1984 to 86 time frame. I called it APF 07, and that's my initials, by the way, first event recorder. Here are some descriptions. You can pause the video and read in detail. Here's a wiring diagram. Here's the schematic. Here is a simplified schematic diagram to illustrate how the system works, the principle of operation. So at the bottom is the CD4017 decade counter. It will step through 0 to 5, and these gates will be tested. A, then B, then C, and so on. It will continuously scan until it finds that an input went active. So on this slide, it scanned until input number 3 triggered. It will stop and the normal low line will go high, and line 13 on the 4017 chip will go high, and that will stop first scanning. This power alarm will start to flash, and it will stay in this state even if number 3 cleared, or even if it was just a pulse. It will latch onto that input, and LED 3 will stay on until the operator pushes the reset button. I did not have 6 optocouplers at the time. I did build a system earlier, a 2-party hotline that used optocouplers, but for this project I did not have these optocouplers available, so I designed this circuit around it. Normally, it is best practice to put an opto isolator to protect the CMOS chips to withstand EMI, RFI, and provide rejection. This first event recorder instrument was my original work from concept to design to construction. It was not derived work, it was not built from any template, it was not a copy of anything. I architected the solution, designed the schematics, built the circuit board by hand, and did the entire assembly 100%. I had a microprocessor training kit, MPF1, somewhere around 1983 to 84, and I was training on embedded systems, learning how to program the Z80 chip. Still training on it, learning assembly language. I was still trying out my microprocessor and learning embedded systems, learning how to write assembly. I tested code. I saved off these programs to a tape cassette, but I was not able to build a microprocessor-based system. That would be too much at that time. This is Aston Francis, and thanks for watching.